Okay, here we go. Volumes of right pyramids and right cones. So let's start off with the volume of a uniform solid. A solid is uniform if its cross-section is the same the entire height of the object. Two examples of a uniform solid are a prism and a cylinder. So with the cylinder, we can see we've got this circular base, and that goes all the way through the object. And with the prism, we can take any of these faces and then just move it all the way. Take the front face, move it front to back, or take one of the side faces and move it side to side, top to bottom, etc. So we have a uniform cross-section all the way through. So the volume of, got to change to a pen here. The volume of a rectangular prism is defined as the area of the base times the height. And the volume of a cylinder is also the area of the base, the circular base in this case. So area of base times height. So let's flesh this out a bit. To calculate the volume of a uniform solid, all we need to do is multiply the area of the base of the object. Now we're going to denote that by a capital A for area of the base, by the height of the object. So we can see with the rectangular prism, we have the area is the area of a rectangle times the height. And the area of a rectangle we know is length times width. Right? And that's the area of the rectangle, and then we'll multiply by height. And to shorten that, we'll just say LWH, length times width times height, using letters. Volume of a cylinder is again the area of the base, but this time that's the area of a circle times the height. The area of a circle is pi times the radius squared. Radius squared, throw little times in there, times the height. And we're not going to use words, so we're going to use our symbols. So we have pi r squared h. So the volume of a cylinder is pi r squared h. Today we will learn how to determine the volume of a right pyramid and a right cone. So let's go take a look at what a right pyramid looks like and a right cone. So what we can see with a right pyramid is that the top of the pyramid, the very top, is directly above the center of this base, and this base can be a rectangular base, so we have a right angle here. And a right cone, again, sort of the same idea. And we have the tip of the cone right above the center. Pyramids. A pyramid is a three-dimensional object with a base that is a polygon. So polygon, many sides, right? You can have 4 sides, 3 sides, 5 sides, 10 sides, 100 sides. That's a polygon. And the sides of the pyramid themselves are all triangles. And they meet at a point called the apex, right up there. If the apex is directly above the center of the pyramid, then it is a right pyramid. We just talked about that. So right above the center, then it's a right pyramid. If the apex is anywhere else, then it is called an oblique pyramid. So if the apex were here, and then that will give us different sizes on our sides. Base of the pyramid could be any polygon, such as a triangle. So a triangular based pyramid, here's the base as a triangle. We call that, it's got a special name, tetrahedron. This is a rectangular based pyramid. A pentagonal base, this has 5 sides. And we have talked about volume. So we want to do the volume of a right pyramid and a right cone. Are these solids uniform? Well, by uniform we mean, does it have the same cross-section every time? And the answer here is obviously no. This cross-section, this circle, gets smaller And the same thing here, we could draw a rectangle in here, but it would be smaller. So these are not uniform solids, and I do not have the pen. So let me just get back the pen. And we will say no. Although these solids are not uniform, their volumes can still be calculated. The volume of the right pyramid is related to the volume of a prism, and the volume of a cone is related to the volume of a cylinder. It wants us to see a demonstration video, so let's see what happens if I click on that. I'm just going to pause here while stuff happens. Okay, I'm watching this for the first time as well, so let's see what happens here. We have a rectangular prism. Looks all like a cube. Now our rectangular pyramids, we're going to want the same size, right? So it's going to have the same size base. It'll just be a pyramid. And we can see these are filled with little bits of stuff. So notice the prism and the pyramid share the same base area. They also have the same height. I'm sort of impatient skimming along, but so we know the formula for volume of rectangular prism is B. They're using B for the area of the base. So let's use the pyramid to fill up the prism and see what happens. Somebody's smart. Usually they do this with water, and then there's water all over the place. One pyramid, and how full does that look to you? Two pyramids. Wish you'd have shaken it just a titch more, but how full does that look? Ta-da! 3 pyramids to fill the prism, which will lead us to a formula. A rectangular pyramid is 1/3 of the volume of a prism. So 1/3 base height, or 1/3 length times width, which is the area of the base times the height. And credit where credit is due. And then what I'm going to do is pause this, and we'll bring up the other video. So here's the pause. Okay, here we are with someone different. Deriving the formula for the volume of a cone. And there is a cone. With subtitles, cone. And there is a cylinder, and it's the same size. You notice the base has the same size as that cone, and it is the same height as the cone. Same base area. I'll let this play. Same height. Ooh, nice. Colored water. Makes it easier to see. So how full does that look? What fraction of fullness? that one, how full? And I don't think we're going to be terribly surprised by what happens next. And we're back. And as we saw, the volume of the pyramid was 1/3 the volume of the prism with the same base area and height. Volume pair is 1/3 volume of the prism, 1/3 the area of the base times the height, or AH. And keep in mind that the base of the pyramid could be any polygon: triangle, rectangle, pentagon. And the second demonstration, the volume of a cone is 1/3 the volume with the same base area and height. And keep in mind that there is only one cone or one cylinder, so area base times height, pi r squared h. 1/3 pi r squared h is the formula for the volume of a cone. Recap: volume of a right pyramid and a right cone. The volume of a pyramid is 1/3 A H, where we're using A, right? A for the area of the base, and the volume of a cone is 1/3 the area of the base, which is a circle, so pi r squared h. Alright, let's go try some out. Determine, meaning show your work, the volume of each figure shown, round to the nearest tenth if necessary. Okay, let me just skip these up a bit. Okay, volume, formula, right? Always formula. 1/3 A H. 1/3 the area of the base. Base is a rectangle. 8 times 15 times the height, which is 20. Okay, do we need a calculator? I don't think so. 1/3 of 15 is 5. 5 times 8 is 40. 40 times 20 is 800. Units, centimeters. Volume, cubic centimeters, right? Remember, this is centimeters times centimeters. That's an area, which would give you centimeters squared, times centimeters, which gives you a volume. And remember, we don't put in the units here. We only put them in at the very end. Here we have a cone. Volume is 1/3 pi r squared h. And r is equal to 7 centimeters. So we always have to look at what we're given. Do we have to do any adjustments? I have a diameter of 14. I want to get a radius of 7. Okay, let's fill in formula. Substitution. You're always going to use the pi key on your calculator. So, but before we get the calculator out, 1/3 of 24 is 8. 7 squared is 49. 8 times 50 is 400, but we only want 8 times 49, so we'll be 8 shy of 400, which is 392 pi. This is exact, and occasionally in mathematics we are going to want an exact value. On the calculator, leftover stuff, let's go 392, well actually, you know what, let's go 1/3 times pi, there's your pi, times 7 squared times 24. 1231.5, we're rounding to the nearest tenth, so V 1231.5 units, centimeters, and it's a volume centimeters cubed, right? That's a 7 centimeters. When you square it, you'll get 7 or 49 square centimeters, which is the area of the base. And then the height is 24 centimeters. Square centimeters times centimeters gives you centimeters cubed. Next, a pyramid. An oblique-ish looking pyramid because, so here I'm going to take this as the base, this 3, 4, 5 triangle is the base, and then this is the height. And you can see all of the right angles here. These are mutually perpendicular, as are these. Right? And again, remember, this is a two-dimensional representation of a three-dimensional object. Formula: 1/3 AH. The area of the base is a triangle, and it's 1/2. The base of that triangle is 3, and the height is 4. Or the base is 4, and the height is 3. But it's the 3 and the 4 that we're using. So base, height, that's the A, and then times 8. Okay, do I need a calculator? Well, 1/3 times 3 is 1. 1/2 times 4 is 2. Times 8 is 16. 16 units, centimeters, it's a volume, so centimeters cubed. Next page. I think it's the next page. Let's check. Oh. That's weird. Where did that come from? Example 2. The diameter of an ice cream cone is 6 centimeters, and the slant height, this is what we're talking about when we're talking slant height. Okay, this is what we're talking about when we're talking height of the cone. This is the height. This is the slant height. This is the radius, which in this case is 3 centimeters. This is the slant height, which is 10 centimeters. And we want the volume to the nearest tenth of ice cream that would fit inside the cone. I don't know why there's a star there, but so volume of a cone is 1/3 pi r squared h. And here's the problem. We don't have h. So we're going to go over here and we're going to draw this guy here. We're going to say we have a triangle that's 3 here. The slant height is 10. I'm going to call that h for height, not to be confused with h for hypotenuse. So to find the height, we know that 3 squared plus h squared equals 10 squared. H squared will be 10 squared minus 3 squared. H squared is 100 minus 9. H squared is 91. So h is the square root of 91. And now we can go back over here and fill in our values. 1/3 pi, again, pi key, 3 squared, and then root 91. This is exact value, and when do we round? Only at the end. Okay, so 3 squared is 9, and 1/3 of 9 is 3. So this will be 3 times pi times root 91. That's a very exact value. We're using pi, we're using root 91. Okay, but we can plug that into our calculator, and I will let you do that. And rounding to the nearest tenth, we get 89.9 centimeters cubed. Okay, so we did have a little bit of work to do here because we have the slant height. I'm just curious what happens if I hit this star. Nothing. That's just a little star there. And back to my line stuff. Okay, keep going. Example 3. The base of a rectangular based pyramid has dimensions 8 feet by 4 feet. Determine the height of the pyramid if its volume is 144 cubic feet. Feet cubed can be read as cubic feet. So, okay, what are we dealing with here? We got a 4 by 8 pyramid. I don't draw well there. So that's 8. That's 4. This is the height H. Volume is 1/3 AH. Okay, what do we got? Well, let's fill it in. The volume is 144. The area of the base, it's a rectangular base, so it's 8 times 4, and then we've got height. And we're kind of back to day 1 stuff, right? We need to solve for H. So we're going to multiply both sides by 3. Get rid of that 1/3. Giving me 432 is equal to, we can multiply this out, so 32H. So H is 432 divided by 32, which works out to 13.5. And it's a linear measure, right? It's just one of the measurements. And so, 8 feet, 4 feet, this is 13.5 feet. Keep going. The volume of a cone is 300 cubic centimeters. If the height of the cone is 14, then determine the radius of the base of the cone rounded to the nearest tenth. Okay, I'm not even going to try and draw a cone, so let's just, volume is 1/3 pi r squared h. We know h, it's r that we want to find, and we know volume. Okay, so let's go fill in. 300 is 1/3 pi r squared. Remember, it's r we don't know, and h is 14. So I'm going to multiply both sides by 3. 900 is 14 pi r squared. I now have to divide both sides. We need to isolate the r squared, right? That means we're dividing by 14 pi. So 900 over 14 pi equals r squared. Flip sides here, so r is equal to the square root of 900 over 14 pi. That's an exact value, right? Then we can plug that into our calculator, so let's do that on. So I want the root of 900 divided by 14. And I'm putting brackets down so that it will do the 14 pi, right? Because the 900 has to be divided by 14 pi. Otherwise, we'll get 900 divided by 14 times pi. I'll show you that in a sec. So r is equal to the nearest tenth, 4.5 centimeters. So let's do it wrong. What if I went 900 divided by 14 pi? Now, so we get a different answer, because what it's doing then is order of operations. It's going to go 900 divided by 14, then multiply that by pi, and then take the square root. And what we really want is 900 divided by 14 pi, right? This division bar here says you are taking, work out the top, work out the bottom, then do the division. And so I had to put brackets around that so that it would work out the bottom. Next. Oh, wait, is that it? I believe that's it. Hey, under 24 minutes.